Hi everyone, it's Mrs. Giesbrecht. Since quite a few of you were gone, I decided to put together a video for you to watch on the quadratic formula, so that way the minute that you are done with the video, you can jump on in and work on your worksheet. So what we were learning in class is that sometimes when I have my graph and I'm looking for my intercepts, they don't always cross at a perfect whole number. Sometimes they're a crazy decimal. And we've been using Desmos to help us find those intercepts. But if Desmos is not an option, we do need an algebraic way to be able to solve for those roots, for those intercepts. And that way is called the quadratic formula. So as you guys are watching this video, feel free to click pause at any time, write down any notes that you need. So let's start with the formula itself. The formula itself looks kind of crazy scary, but it's really not that bad, so just hang in there with me. Take a moment, push pause, and copy down the formula, then hit resume when you're ready. So when we're looking at the quadratic formula, what we're really looking at are all of these crazy letters. So we have x equals. The reason that this is an x equals is because from the graph, we're looking for the x-intercepts. So x is going to be negative b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. Now where these numbers come from is if you think about our original equation, we have our f of x equals ax squared plus bx plus c. So our a is always going to be the number in front of the x squared. Our b, I don't know why that's black, it should be a really nice color. Our b is going to be the number in front of the x, and our c is going to be the number that is all by itself. So what we're going to do is we're going to try a couple examples together. When I first set up my equation, I always like to go through and give myself what I call a skeleton equation, meaning it's going to be the equation you see above, but wherever I see a variable, I'm going to leave it and write it as a parenthesis. So let's try our first example together. Example 1 is going to be x squared minus 5x minus 24 equals 0. So my step 1, before I even write out my skeleton equation, off on the side I want us to label what a, b, and c values. What are those values? So a again is the number in front of my x squared. So let's see, what do we think that's going to be? My number in front of the x squared. B is my number in front of the x. And c is the number by itself. So let's fill those in. So my a is going to be a 1 because that's in front of my x squared. My b is a negative 5. And my c is a negative 24. It's really important to include the sign that's in front of those numbers when you're picking out your a, b, and c values. So now let's jump into our formula. So let's remind ourselves what it was. Negative b plus or minus square root b squared minus 4ac, all divided by 2a. So let's make our skeleton equation. Wherever you see a variable, let's put in a parenthesis. So pause for a second until you have your skeleton equation, then you can click resume and jump back in with me. So what we're going to do now is let's take a peek at each parenthesis and let's put in the appropriate value. So over here on the side, it is showing me that my a is 1. So let's look. In my equation, I have 2 a's. I have an a right next to the 4, and I have an a in the bottom. So let's fill in those 2 spaces with my a value. Next, let's look for my b values. So my b is a negative 5. So wherever I see a b, I need to put in a negative 5. And my last remaining value is my c value, and wherever I see my c, I'm going to put in a negative 24. From here, we just need to simplify my equation as much as possible. So let's work on that together. Out in front, I have a negative 5. Negative 5. That's going to turn into a positive 5. plus or minus. Let's work on my square root portion. So right now I'm right here. Negative 5 squared. So negative 5 times negative 5 is a positive 25. Then take a peek at the last part of my equation. It is all three numbers multiplied together. So negative 4 times 1 times negative 24. So my negative times a negative is going to change into a positive. And 24 times 4 is going to be 96. All divided by 2 times 1 is 2. Okay, we're doing great. Let's continue on. Let's simplify a little bit more. So I'm going to just leave it as a 5. I didn't really need my plus 5 in front of there. Plus the negative. 96 plus 25 gives me 121 divided by 2. Let's keep going. We're almost done. 5 plus or minus the square root of 121 means what number times itself is 121? That's 11 divided by 2. So I kind of have this funky answer here. I have this plus or minus going on, and I'm not quite finished yet. So I'm going to switch slides so I give myself a little more room, and I'm going to rewrite what we have. So we have 5 plus or minus 11 divided by 2. 5 plus or minus 11 divided by 2. This is really two separate problems. I'm going to write it once with the plus sign, and I'm going to write it once with the minus sign. So on top I get 16 divided by 2 is 8, and on the bottom 5 minus 11, negative 6. Negative 6 divided by 2 is negative 3. Think about why there would be two answers. Think about what we were really looking for at the beginning. At the beginning it said x equals. That means these are my two x values. So that means my graph is going to cross at 8, and my graph is going to cross at negative 3. So what you guys just found using the quadratic formula were your two intercepts. So far this chapter we have learned to find these intercepts by factoring and then setting each parenthesis equal to 0. That was the zero product property. And now we have another way called the quadratic formula. So the reason why you guys would want to use quadratic formula is for those times when on my graph they don't always cross to those perfect whole numbers. Sometimes we're going to get those decimals. So quadratic formula is always going to work for us even when factoring doesn't. So let me give you an example. Let's try one more. So we'll call this example 2. And my equation is 2x squared plus 7x equals 11. Now what's unusual about this question is that you are not allowed to tell me A, B, and C just yet. See if you notice something about the way that this problem is written. And what's strange about it is that the 11 is on the wrong side of the equal sign. All three values to be in standard form have to be on the left-hand side. So I'm going to go ahead and move that 11 over. Equals 0. So when I move the 11 over, now you're able to tell me A, B, and C. So my A, the number in front of my x squared, would be a 2. My B, the number in front of my x, is a 7. And my C, the number all by itself, is a negative 11. So the reason that you guys have to use quadratic formula on this problem is that if you guys tried to factor it using your magic diamond and then your generic rectangle, it wouldn't work. It would be what we used to call prime. So now we have another way to find those intercepts. So let's go ahead and write my blank equation. So my negative b plus or minus square root b squared minus 4ac all divided by 2a. Now let's go back in and fill in my numbers. So my b value is going to be a 7. My b value is a 7. Then it's 4ac. My a is a 2. My c is a negative 11. and on the bottom, my a is a 2. From here, we just have to simplify. So in the front, I have a negative 7 plus or minus. 7 squared is 49. Then I have 3 numbers multiplied together. So this is kind of the one main spot where students make mistakes, is right here. These 3 are all multiplied together. So negative 4 times 2, negative 8. Negative 8 times negative 11 would be positive 88. All divided by 2 times 2, which is 4. So from here, we're going to say negative 7 plus or minus square root 49 plus 88 gives us 137 divided by 4. So for today, this is how you're going to leave your answer, because we don't know, we haven't learned yet, we will later this week, how to do the square root of 137. We know a calculator could do it for us, but I don't want the calculator doing it for you at this point. We're going to have another method to solve the square root. So if it's not a perfect square root, if it's not something that we know automatically how to do, you guys are going to leave your answer just like this. So I'll be handing out a worksheet for you guys to work on, and you're going to do as many as you can. If they come out perfectly, like our last example, example 1, we got 2 whole numbers, awesome, find them. But if you guys come up with the square root that we don't know, we know it's going to be some kind of a decimal, you're going to leave your answer just like this. And then tomorrow I'm going to teach you how we can reduce those roots. All right, hope this was helpful. Good luck on your worksheet.